let's take a look at number 30. So it says use the change of base formula to evaluate the logarithm. How would I evaluate this? Awesome. Log of 42 divided by log of 23. You have to take the log of both of them. Remember, base goes on the bottom. So then we would just put this in the calculator. Make sure you know how to use your own calculator. If you do it all at once, you have to close the parentheses. So log of 42, close the parentheses, divided by log of 23. A lot of people made that mistake on the quiz, that you didn't close the parentheses. So when you put this in the calculator, you got a wrong number. So it should be 1.192. Any questions here? So let's look at 32. How would I solve a log equation? George. How do I cancel out the log base 3? Make the big base 3. So what we do on one side, we have to do to the other. So it cancels out the log base 3. 2x minus 5 is equal to 3 squared, which is 9. Then we just solve for x. So what would I do next to solve for x?
Plus 5, 2x to 14, x to 7.
Awesome. X is equal to 7. Perfect. All right, so let's do an exponential question now. Number 3. What could I do here?
Change the 9 to 3 squared.
Awesome. You want to be careful when changing that you're not changing the values, but 3 squared is still 9. Still has that same value as 9, so I'm changing it to 3 squared. So I have 3 to the power of x plus 1 is equal to 3 squared to the power of x minus 3. Whatever our exponent that's already there, we just multiply it to the new one that we got. So what do I do once my bases are the same? Cancel them out. So then we just set the exponents equal to each other. So x plus 1 is equal to 2x minus 6. I'm going to distribute that. And then what? Yeah, we want to make the base the same so our bases can just cancel. So you can change one of your numbers to make the base the same, but just make sure you're not changing the value because 3 squared still has the same value. So we can subtract x and add 6. So 7 is equal to x. So looking at 6, there was a question super similar to this on the quiz. We want to make the bases the same because they both have exponents. So what do you think I could make a similar base for these two be? I'm not sure if we could change 4 to, like the 1 over 4 to be a 16, because then we would be increasing the value of it. So I could change 16 to be 4 squared. And I could change 1 over 4. How would I make that 4 to some exponent? 4 to the power of negative 1. So what a lot of people did on the quiz was they did 1 over 4, but changed it to be 4 to the power of negative 2. 4 to the power of negative 2 would be 1 over 16. So it changes the value. It's not 1 over 4. So that was the most common mistake. You could have changed it to be 1 over 16 to the power of negative 1/2, and then that would have changed it to be 1 over 4, but then you would have also had to change this one too. So I think the easiest way to do it would just be change 16 to be 4 squared, and then change 1 over 4 to be 4 to the power of negative 1. And then the exponents stay there, so 3x minus 2 and 5 minus x. Yes. What would I do next? Got to multiply the exponents, and I can cancel out the bases. If my bases are the same, they can go away. So I got 6x minus 4 is equal to negative 5 plus x. What would I do next? Solve for x. So we combine our like terms. So 5x is equal to negative 1. So we subtracted x and added 4 and divide by 5. So x equals negative 1 over 5. All right, so for 17, if we have 2 logs, what do we do? Condense it to 1. How do I condense when I'm adding? Multiply. So log base 6 of 2x squared times 3 is equal to 2. How do I get rid of the log now? Make the big base 6. So it cancels. So 2x, well, I'm going to multiply here. So I'll make it 6, because 2 times 3 would be 6x squared is equal to 6 squared. What's 6 squared? 36. Then from here, we just solve for x. So divide by 6. X squared is equal to 6. Take the square root of both sides. So x is equal to what? Plus or minus square root 6. You always want to check and see if they both work. If I plug in negative square root 6 here, when I square it, it's going to turn positive. So both of them actually work as our answers. So this would be our answer here. All right, so just as a reminder, for inverse and direct variation, our inverse variation formula is y is equal to what? A over x. So it's when x is being divided. Our direct variation formula is y is equal to a times x. So when x is being multiplied, if x is on top. Let's look at number 3. For these questions where we have to determine if it's direct, inverse, or neither, we need to make it y equals. So how could I make number 3 y equals? Awesome. Multiply the y. We want to get the y from out of the denominator so we can multiply it on both sides. So I have 15y is equal to x. And then what would I do? Divide by 15. So this one is actually direct because it's the same thing as saying y is equal to 1 over 15 times x. 1 over 15 is that a. So because x is on top, it's direct. So when x is on top of the fraction, it's direct. It's only when you're dividing the x, if x was on the bottom, that it's inverse. So this is direct. Any questions here? Okay, let's look at number 4. What should I do here? Got to get the y all by itself. Move the 3. So we can add 3 to the other side. So y is equal to 2x plus 3. What do we think? Neither. Because that has that plus 3. It's not just 2x. It's not just multiplying or dividing the x. It has that plus 3, so that makes it neither. Let's take a look at number 5. So here we need to figure out if it's inverse or direct variation or neither. So I'm going to make my chart. I need to multiply x times y. We also need to divide y by x. Okay, the reason why we do x times y or y divided by x is because we're trying to solve for a. We're trying to figure out which one has that constant a. So to solve for a in my inverse variation, I would have to multiply x on both sides. So a would be equal to x times y. So if x times y is a constant, that means that it's inverse variation. We do the same thing with direct. We're trying to solve for a, so I would have to divide x on both sides. So if a is y divided by x, if y divided by x is a constant, then that would mean that it's direct variation. So we're looking to see which one has a constant here. I'll go back to that, but x times y would be inverse variation. Y divided by x is direct. And this is why, because it's when you're solving for a. So let's figure out which one we got here. So x times y, we're multiplying the columns together. What is 7 times 35? Times 7 times 35. 245. What about 11 times 55? Are these a constant number? No. So it's not going to be inverse variation. As soon as you see that it's not a constant, you can cross that one off. It's not inverse variation. Let's check y divided by x. So it's 35 divided by 7? 5. What's 55 divided by 11? 5. 75 divided by 15? And 100 divided by 20? So which one do we have here? Direct. What if y divided by x wasn't a constant either? Then it would be neither. So for the table, it helps to make your own table, figure out what x times y is and y divided by x. Let's take a look at 7. So it says the variables x and y vary inversely. If it's inversely, what formula are we using? Y equals a over x. Use the values given to write an equation relating x and y. Then find y when x is equal to -3. So first thing we have to do is write an equation. Step 1, write an equation. So I'm using y is equal to a over x. How would I find what a is? Plug in the variables. So I can plug in 1 into x and 5 into y. So 5 is equal to a over 1. Multiply 1 on both sides, which is just 5. So a is equal to 5. So my equation would be y equals what? Y equals 5 over x. Perfect. For your equation, you're going to have the variables x and y in it. The only number that you're plugging in is a. Now for the second part of this question, it says find y when x is equal to -3. So I'm going to plug in -3 into x. So y is equal to 5 over -3. Divide if you can, simplify, but here we can't simplify. So we can just leave it as 5 divided by -3. All right, let's take a look at 15. It says the current y in a certain circuit varies inversely with the resistance x. So the current is y and the resistance is x. If the current is 8 amperes when the resistance is 20 ohms, what will the current be when the resistance increases to 25 ohms? So it says the current is 8 amps here. Does that 8 go with the x or the y? How do you know that it's the y? Because it says the current. It's talking about the current, and current is y. So the current is 8. So it says that it varies inversely. We use y is equal to a over x. 8 is going to be y, because we said it has current. And then let's read the rest. It says the resistance is 20 ohms. 20 would be what? X, because it says resistance is. The resistance is x, so 20 would be x. So we're going to plug in 8 into y. So y is equal to a over, and 20 goes into x. Okay. So how would I solve for a? Multiply by 20 on both sides, so it cancels out. So I get 160 is equal to a. So just like I did with the equation before, I'm going to take the 160 and plug it into the A. So my equation is y is equal to 160 over x. So this would be my equation, and it says, what will the current be when the resistance increases to 25? So what am I going to plug 25 into? X. How did you know X? Because it's talking about the resistance. So when I plug 25 into X, I have y is equal to 160 divided by 25.
That would be, you could do 5.
6.4. You could either simplify your fraction or just put it in your calculator and give me a decimal. So 6.4 amps. So that's what the current is measured in. All right, let's move on to 7.3. We're going to start with the multiplying one, number 14. So a couple different ways we could do this first. We could either simplify right off the bat, or we can multiply it together and then simplify. I'm going to say let's multiply it and then we'll simplify. So we're going to just multiply the tops together and multiply the bottoms together. So combine like terms. What is x to the 4th power times x? X to the 5th power. Perfect. When you multiply, you add the exponents. So I have 80 times x to the 5th power times y. And then on the bottom, do I have any like terms here? No. So just 5x squared y to the 3rd power. So now let's simplify our like terms. So I have 80 divided by 5. 16. Would the 16 go on the top or on the bottom? On the top. Okay. Then we can worry about our x's. So I have x to the 5th power divided by x squared. So how do you know that it's x to the 3rd?
You just take out 2 x's.
You take out 2 x's from the top. So if you want to, you can write out however many x's you have. We have 5 on the top and 2 on the bottom. So we just cancel out 2, and we're left with 3 of them where? On the top. So x to the 3rd power. We're going to do the same thing with our y's. How many y's do I have on the top? 1. How many y's do I have on the bottom? 3. So 1 pair will cancel out, and how many am I left with?
-2.
2
So you have to go to the bottom.
on the bottom. Perfect. So y squared on the bottom. Now we have to state our domain. So it's whatever we canceled out does not equal 0. So what did I cancel? What did I cancel here? X. So x does not equal 0. What did I cancel here? Y. So y does not equal 0. So whatever you cancel out, you have to say that that does not equal 0. So for the simplifying, multiplying, and dividing, whatever you cancel out, you have to say that that does not equal 0. So for number 2, we are simplifying the expression. What would I do first to simplify this? Factor. So first step is to factor. So we factor the top and the bottom separately, like as if they're 2 different factoring problems. What are 2 factors of 6 that add to 5? 3 and 2. Because 6 and 1, neither one's negative, so it wouldn't work. So 3 and 2. So this factors into x plus 3 and x plus 2. Now let's look at the bottom. What are 2 factors of -3 that add to 2? 3 and -1. Be careful with your signs. So x plus 3 and x minus 1. Does anything cancel? The x plus 3's cancel. Is that it? Yep. So x plus 2 over x minus 1. And then what do I have to do next? The domain. I have to say x plus 3 does not equal 0. So I subtract 3 on both sides. So what does x not equal? -3. Perfect. Can I just cancel out these x's here? No. Because X plus 2 is one thing. X minus 1 is one thing. So you can't just cancel out x's unless they're being multiplied. So only when it's being multiplied to something else, that's when you can cancel. Notice here we're multiplying these two together so we can just cancel them out. Let's look at number 8. So here we are multiplying. What's the first thing we should do? Step 1, always for these types of questions, what do? Factor. So the top left, let's start here. We're just going to factor one thing at a time. How do I factor the top left? Anybody? Take out an x. We're going to take out the GCF, which is x. So I have x, and what am I left with when I take out an x? X plus 6. Perfect. Whenever you have two terms, it's either going to be the difference of squares or a GCF. So just make sure you check and see if you have a GCF. Bless you. Can I factor the bottom? Nope. So it's just x minus 4. And then let's factor the top right. What are two factors of -8 that add to -2? -4 and 2. Perfect. So this factors into x minus 4 and x plus 2. Awesome. I'm going to write everything together over here just so we can kind of see a little bit better. So I have x plus 6, x minus 4, x plus 2 on top. And then on the bottom, I have x minus 4 and x. So I had that solo x there too. The x minus 4's cancel. Perfect. Anything else cancel? The x. So the x and the x. Yeah, you just put them all together and cross out whatever's in common. So then we are left with x plus 6 times x plus 2. Do I have anything left on the bottom? No. You don't have to FOIL, you just leave it like this. Don't FOIL it back out. What do I need to do next? Find the domain. So what did I cancel out? X minus 4. So x minus 4 does not equal 0. So we add 4 to both sides. So x does not equal 4. What else did I cancel out? X. We have to say x does not equal 0. So x does not equal 4 and 0. So this would be our answer. Let's look at 13. So 13, we are dividing. This is find the quotient. Also gives us the little dividing sign. What do we do first when we divide? Keep, change, flip. Keep the first one, change to multiplication, flip the second. So I'm going to keep, change, flip down here to make a little bit more space. So 2x cubed plus 10x squared over x squared plus x minus 20 times, because I changed to multiplication, and flip the second one, x minus 4. So 2x squared. What do I do next? What do I do next? Factor. So let's start with our top left hand over here. Awesome. We're going to take out our GCF, which is 2x squared. What am I left with when I divide out a 2x squared? X plus 5. Because we divide the 10 by 2. So 2x squared times x plus 5. Let's factor the bottom now. What are two factors of -20 that add to 1? 5 and -4. Perfect. So on the bottom, we have x plus 5 and x minus 4 times. Top on the right side's already factored, so it's just x minus 4. And then the bottom is just 2x squared. So let's cancel things out. What cancels? So x minus 4's cancel. X plus 5's cancel. And what else? 2x squared's cancel too.
So this is
So what do you think my answer is if everything cancels?
a 0, 1.
1. Awesome. Because remember, if you have something like 5 divided by 5, if you divide something by itself, you're just left with 1. So our answer is 1, but we still have to say the domain. So what did we cancel out?
X plus 5.
X plus 5 does not equal 0, so we subtract 5. So x does not equal negative 5. What else?
Minus 4.
X minus 4 does not equal 0, so add 4 to both sides. X does not equal 4.
And
2x squared does not equal 0. So how would I solve for x here? You can divide by 2, cancel it out. So x squared does not equal 0. Then what? Square root. What's the square root of 0? 0. So x does not equal 0. So our answer is 1, and x does not equal negative 5, 4, and 0. All right, let's do one more. 14. So what do I do first for 14? We could factor first. I'm just going to keep change flip so we don't forget about that. Because whenever we divide, don't forget to keep change flip. What am I flipping for the second part of this? You put it over 1, so then we flip that. So I have x squared minus 10x plus 21 over x plus 2 times, because we changed to multiplication and flip our second fraction. So 1 over x squared minus 14x plus 49. Now we can factor. So what are two factors of 21 that add to negative 10? Negative 7 and negative 3. Perfect. So x minus 7 and x minus 3. The bottom's already factored for us. We just have x plus 2. Times on the top we have 1 here. And then let's factor the bottom. What are two factors of 49 that add to negative 14? Negative 7 and negative 7. So x minus 7 and x minus 7. What do we do next? Cancel. What cancels? X minus 7. Can I cancel out both x minus 7s on the bottom? No. Only a pair. So only one thing on the top and one thing on the bottom you can cancel. So I am left with x minus 3 over x plus 2 times x minus 7. What else? The domain. So we got to say x minus 7 does not equal 0. Whatever we canceled out does not equal 0. Add 7 to both sides. So what does x not equal? 7. You don't have to FOIL out the bottom. Just leave your factors. Save yourself some time and work. Just leave it as the factors. Don't FOIL. Just to be super sure we are good on factoring, what if I have one that was x squared minus 36 over x minus 6? Perfect. The top factors into what? X plus 6, x minus 6, because it's the difference of squares. And then we have x minus 6 on the bottom, so these cancel, and I'm left with x plus 6. And what can x not equal? X cannot equal 6. We would say x minus 6 does not equal 0, so x does not equal 6. Perfect. All right, so I'm going to do number 5. I'm going to rewrite it over here. So x to the 4th power minus 16 over 5x cubed minus 3x squared plus 20x minus 12. All right, let's start with factoring the top. How would I factor the top? That's the difference of squares. So So it would factor into x squared plus 4 and x squared minus 4. Which one can we factor more? Just the minus. So x squared minus 4 factors into x plus 2, x minus 2, because this one also is the difference of squares. So when we factor the whole top, we get x squared plus 4, x plus 2, x minus 2. Now let's factor the bottom. How do I factor when I have 4 terms? Grouping. Group the first 2, group the second 2. Take out the GCF in each group. So what's the GCF in the first group? X squared. So take out an x squared and we're left with 5x minus 3. What's the GCF in the second group? 4. So we take out a 4 and we're left with 5x minus 3. Perfect, because the insides have to be exactly the same in order to factor by grouping. We put the outside 2 together, so x squared plus 4. And then we put the inside ones together, 5x minus 3. So we got x squared plus 4 and 5x minus 3. So x squared plus 4's cancel, and that's it. So we're just left with x plus 2, x minus 2 on top, and 5x minus 3 on the bottom. And what else? So x squared plus 4 does not equal 0. We subtract 4 on both sides. X squared does not equal negative 4. Then what would we do? Square root both sides. Can I take the square root of a negative? No. So this ends up being an imaginary number, so we don't even need to include it because it's not a real number. We just don't put it in our answer. Nope. So let's say we had x squared minus 4 does not equal 0. We add 4, so we get x squared does not equal 4. Then when we take the square root, we can take the square root of 4. So it would be x does not equal plus or minus 2. So that would be if it was a positive 4. Because don't forget, when you take the square root of both sides, you need the plus or minus. Yes. One other one that I wanted to do, just as a bonus example. Let's say I had x to the third power plus 6x squared over x times x plus 6. What would I do here? So factor the top first. We're going to take out the GCF. What's the GCF? X squared. When we take out x squared, what are we left with? So x squared times x plus 6. Perfect. We just divide out the x squared from both of these. The bottom is already factored for us. So we have x times x plus 6. All right. What would we do next? X plus 6's cancel. Anything else? So I can cancel out an x with what? Both of the x's on top? Just one of them. So what am I left with? Just an x on top. So just x. So we can cancel out, this is 2x's. This is like saying x times x. We can cancel out one of the x's on the bottom with just one, but we're still left with one there. And then what do I have to write in my answer? Perfect. So we would say x plus 6 does not equal 0. Subtract 6 on both sides. So x does not equal negative 6. And we also got to say x does not equal 0 because we canceled out an x. So x does not equal 0. So that would be our answer. So if we had something like this, oops, if it was x times x plus 2 over 3x, we could cancel out the x's here, and we'd be left with x plus 2 over 3, but we'd have to say x does not equal 0. So let's say on top we had and then on the bottom, let's make it x minus 1. Are these exactly the same? Are they? No, because this one
No, it's negative 1 plus x.
has a negative x, this one has a positive x, so they're not exactly the same.
That's 1 minus x.
But could I maybe change it to be exactly the same? How? I'm not going to multiply it by negative 1, but I can divide out the GCF and make it negative 1. So I'm going to put a negative 1 on the outside, and then I have negative 1 plus x, which if I reordered the inside here, I'm just adding so I can rewrite it in whatever order I want. I have x minus 1 over x minus 1. So then these cancel, and what am I left with? Negative 1. So if it's almost exactly the same thing, see if you can take out a GCF, like a negative, and just flip the signs. But that negative 1 doesn't go away, it's still just out front. It's just the GCF that you divided out. Yeah, and then we would have to say x minus 1 does not equal 0, so x does not equal 1.